Awesome, awesome. We are on. So we are going to go to our next agenda item. And today we'll be looking at two things. Let me just get the notes opened from where I'm at. So today, this afternoon, we are going to be looking at two interesting topics. One of the topic is introduction to computing, and then immediately after that, we'll be doing basic computing concepts. So those are the two units that we are going to cover. We are going to cover in a minute or so. So, as I told the earlier class, just to build engagement kidogo, how was your lunch? Niambieni hapo kwa chat, how was your lunch? How was the break? Do you feel like you've refreshed, ready to go on? Na mnanijua, by the way, if I tell you to talk to me in the chat section and you don't talk, I'll just call you by name, especially watu wa channel yangu. So you know how I do it. Nataka kuona mtu hapo aniambia, hata kusema fine is still okay. I just want to make sure that you guys are up. Najua tricky things with these classes za saa 8 watu wanaweza doze. Watu wanaweza doze. Frank, how was your lunch? Franco, how was your lunch? You can unmute. Oh. It was great. Awesome. Mark, unasema uliinama ukacha ipite. Wewe. That's interesting. Elfas, it was fine. That is good. Frank, I can see it was great. Feeling prepared for the afternoon. That is awesome. That is good. That's awesome. That is awesome. So, yes. Ni kuinama tu, but ndio life. But ndio life. Sawa. Mine was great. At least I took some time to rest kidogo, just for the session changeover and also prepare for this class. So I trust mko tayari na mko macho. We are ready to start our session right now. So maybe just to let you know is that by the end, once we are done with these two units, you'll be doing two cases and knowledge checks. So you'll be doing the knowledge checks after this, and the knowledge checks, you'll be doing them in your breakout sessions. Leonard, you're feeling cloudy, I can see you. So we will be doing those cases, and then do we really have a lab to do in the afternoon? I'll check and I'll let you know if we have a lab that needs to be done. But at least one of the things that you will do in addition to the cases, you'll be filling the first exit ticket. You'll be filling the first exit ticket. But hey, have I shared my screen? Now, okay, maybe I see if you guys are seeing my screen. Just a sec, sorry for that. Let me share so that you guys can see. You guys can see, okay. Good. So someone confirm to me that you can see my screen. Yes, thumbs up or voicing. Yes, thank you for that. So this is what I mean by the exit ticket. This is what I mean by exit ticket, and I'm going to talk about the exit ticket once I'm done covering. Okay, awesome. Thank you. So I am going to talk about the exit ticket once I'm done with the content so that you know how to fill it. It is not something difficult, but remember I've talked about the two cases that you guys will be doing. So make sure you do your cases under the guidance of your channel leads. So let us start with our first lecture, which is Introduction to Computing. And this is just an introduction. I know one of the criteria that we use to select this cohort is that you guys have a background in IT, any background in IT. So you don't really need to have a deep background as in computer science and stuff for you to understand what we are talking about in this next two sessions that we'll be having, these two modules that we'll be covering. So, Introduction to Computing. So by show of hand, This is a funny one because, well, but by show of hand, how many of you can say that you know your way around a computer? By knowing your way, it means you can shut it, yeah, you can turn it on, you can shut it down, you can run programs, you can install a program, you can download a program, you can send an email. Let us see, let us see, let us see, let us see. I want to see those hands. Raise your hand and keep it raised. Raise your hand and keep it raised. Raise your hand and keep it raised. And these things that we do, we don't just do them for fun, telling you guys to raise hands, to react via thumbs up. All that counts into your engagement. And it also helps us to know who is not in class. They've just turned on their devices and disappeared. Yes, so raise your hand and keep it raised if you know your way around a computer. Awesome, awesome. Angela, do you? Jama, do you? Mohammed, I can see you. Oh, Mohammed, I can see you. Bashir, do you know your way around the computer? Okay. Naona watu
Yes,
inabidi
dear.
washulie. Inabidi ni washue ndo muinue mkono. Very nice. Very nice. So that is good. It's good that you guys know your way around the computer. So my work is actually easy here because if you didn't, then I would have to go back and even start talking about the history of computers from the days that they used to occupy like a full room to now that we have them almost just occupying a palm. So the computers have come a long way to be what they are today. They've come a long way to be what they are today. If you got an interest and just looked at the history of computing just in brief, maybe you would have seen that even the computers themselves emerged as something that was meant to just share data within a very small space. But now they discovered that the data that you are getting here, we wanted to correlate with data in our other branch. So they started doing a network connecting one place to the other. Oh, sorry, please unraise your hands. You can unraise your hands. Sorry. I forgot to tell you that. Just unraise your hands. Thank you. Thank you for being so cooperative. So I was saying, computers, when they started, they just started as a tool to help one organization to just have its data computed within an within one branch. But now they discovered the need to share this data with another of their branches. I think it was the military. So they were looking for a way to make sure that this data can be transferred or can be shared. And so it brought in an element of networking. And so from there, the computer grew to what we have today. So even this thing that people here we call the internet is just a connection of computers, different computers communicating over a network in a larger scale. So that is what we call the internet. And we'll be talking a lot about the internet and about networking. When we'll be doing a unit on networking, there is a dedicated unit on networking. But right now, we just want to look at introduction to computing. And by the end of this course, these are the two objectives that we hope you will have achieved. One is to express the value of technology. You will learn how to do the following. One, express the value of technology, and two, to define basic computing terms. Basic computing terms. So your digital world, you guys are so lucky. Most of us have been born into a world that we consider digital, a world that we are able actually to communicate with people on the other side of the globe. Like right now, I might be here in Kiambu, Kenya, and I'm communicating to someone in Eldoret. There is another person in, let's say, Malindi. There's another person, just my neighbor around here in Juja, So all these things have been made possible because we live in a digital world. And in this digital world, there are so many things that you are able to do. There are so many things that you're able to do. And now, just as this slide says, your last online experience, what was the last thing that you did? Did you purchase an item from Amazon, for example? Did you watch a video? Did you chat with a friend? Did you play a video game? So, by show of hand again, if you've ever purchased anything online, please raise your hand. If you have ever purchased anything online, please raise your hand. And please mute yourself if you're not talking to us. Okay, nice. Hey, you guys, yani, I have seen. I have seen some people who have never purchased anything online. Priscilla, you've never purchased anything online? Alphas, Prudence, Dan. I can see you guys. I can see you guys. It does not mean that you must have purchased it from Amazon. There are other marketplaces that you can purchase from. For instance, an equivalent to Amazon in our Kenyan context are places like Jumia, like what is the name of this place? Kilimall. There is Gigi and the rest. There is even the Facebook marketplace, you know, all these marketplaces. So you can raise your hand. Thank you for that. And I believe that almost all of us, not almost, actually all of us, and if you've never watched an online video, you'll be watching a video of yesterday's class and today's recording. So that is watching content online, watching a video online. And I believe you guys have been to YouTube. You guys have used Netflix and stuff like that. So that is watching a video online. Then chatting with a friend. Since you guys are on a WhatsApp group, that is one of the ways in which we chat with each other. Playing video games, for those who love to play video games like me, we've played video games online. So these are things that we are able to do in a digital world. We are able to do them online, you know. So question here is, what did you use to get online? So some of the things that we used to get online are, for instance, nowadays we use our phones. Our phones are internet enabled. Sorry, they are internet enabled, they are connected to the internet. So we are actually able to access almost everything that we would access on a computer or on a laptop or on a PC or on a desktop. And then if you have a game console, say you have an Xbox or you have a Nintendo Switch or you have PS, all those can also be connected to the internet, and you can play with your friends from different places. If you have applications, either you have downloaded them from the Play Store, from the iPhone iOS store or something like that, or you have even downloaded web apps, or you have web apps that are running. All that, you use them online. You use them to get online. And then, of course, we talked about the internet, which is the interconnection of different computers. So think about the last thing that you did online. Perhaps it was to purchase an item, as we have spoke about, chat with a friend, play an online game. How did you do it? And you can see that today you can use many different types of devices and platforms to achieve these goals. Things like smartphones, desktop computers, game consoles. All of these things are possible for you to use. And you can see even this course that you are currently attending, you are attending it over the internet. So this is also something that you are able to do. And I know that it is possible for you to join Zoom via phone. You can join Zoom via tablet. Sorry, you can join Zoom via your computers. You see, all that is possible. So technology is part of your daily life and your digital world. That's why we say that it's very important for you to be tech savvy, for you to understand how to use technology for your benefit, because these are some of the things that you can do using technology. Number one, you can get an education. Again, back to this course. This is an education that you guys are getting, and you're getting it by the assistance of technology. Then number two, you can shop online, as you have just discussed. You can use the platforms that we mentioned, the likes of Amazon, the likes of Gigi, the likes of Jumia, all that. Then you can keep track of your finances. There are many awesome applications that you can download even to your phone from a place like Play Store to help you track your finances, to know where your money is going in terms of your expenditures. Then you can use it to secure homes. We have these things we call smart homes. You can use technology to secure your home and just make sure that your home is secured and burglar-proofed. And then you can also use technology to communicate with others, the way I'm communicating to you, the way we communicate to each other, either through video calls, through WhatsApp, either via video or voice call or text. All that is communication. Then you can also use it to entertain yourself through watching videos. Someone told us when we were trying to know ourselves or just to introduce ourselves, someone told us that they enjoy anime, stuff like that. You can go and read poetry, you can read ebooks, all that, whichever kind of entertainment you fancy. Those who love football, you can go and watch football online, stuff like that. There is Netflix for you. There are those many platforms, including the likes of YouTube. Yeah, so all that is available for you, and I'll not read through that because it's the same repetition. And then Just a second. Ivy, what is Ivy saying? Someone is stuck out of class. Let me just see. Just a second. Okay, it's power issue for her. She has dropped. She will join us back. You see, that is what we call communication. It's always important to communicate so that we know what is happening. In case something is of an issue, we can always help you. So as we continue, let us now look at these building blocks of the digital world. So there are different things that come together in order to build the world that we call a digital world. And here we are looking at the likes of applications, computers, networks. All of these taken together are what runs the digital world. So what are applications? Examples of applications that have been given are the likes of mobile applications, web applications, and game applications. Of course, you know, mobile applications are for our phones. Web applications are those that run on the browser, and game applications are those that enable us to play games. As an example, so that I don't want to assume, as an example, someone tell us, what game application have you used? Any gamer in the house, free to unmute. You can also text it in the chat. Any game application that you've used? I don't want to give you some examples. Mtaniangalia funny. eFootball. eFootball. Okay. Is it a web app or a mobile app? Yeah, now both I can see you. Watu wa GTA. Far Cry, I've never heard of that. Oh, it's a mobile app. Awesome. eFootball. Maybe I'll look for it. GTA. Far Cry. I've never heard of that. Oh, the games that people play through Discord. Hey, I can see you, Daniel. My favorite, Project IGI. I love that one. Have you played one or two? There are actually two of them. I think I played one kitambo. Project IGI, both. Okay. If we find an online one, we can compete and see. But you played back in campus. You see, ladies are silent. Why are ladies silent, really? Why are ladies silent? You mean you don't play? Chelsea, good. Chelsea has represented you, ladies. Gummy drop, okay. They detach you from reality. No, it's also a good way of how do you okay, we say everything in Candy Crush. Paraporij hapo hujambia madem poa ati Candy Crush. Mortal Kombat. Belinda, where? Okay. Riju mwana hiyo Mortal Kombat, can you beat that? At Roblox. Awesome. Roblox is also good. It's also good. Awesome. Thank you for that engagement. So those are just some of the games that we have played, that you guys have played. And if you are a gamer and you've not played any of those, maybe you can borrow some examples from our friends there. Now, mobile applications, example of a mobile application that you've used, just again, type in the chat. If you've used any mobile application, let's see, any mobile application. Nataka kuna mwenye atamention enye na expect sana isemwe. Yani Justin umeanza tuna Reddit, Pinterest, marketers, I can see you, X. Watu wa hashtag na waona, Amazon, PayPal app, WhatsApp, Insta, M-Pesa app, nice, TikTok, Jumia, Telegram, WhatsApp, Facebook, Play Store, WeChat, Zoom, good. That's what I was waiting for. I was waiting for Zoom. Aki amunge mention Zoom. Zoom catch. Imagine you're having this class over Zoom and then you fail to mention Zoom. So that is awesome. Yes, now some examples of web applications. Web applications that you guys have used. Even before I tell you what web applications are, notice the difference between a mobile app and nice. GitHub is a web application. AWS is a web app. Another one. Na mtu amemention AWS, mtu akarusha kalove. Mbona umetoa love via ChatGPT, nice, Instagram. Justin kama ujiamini, yes, Gmail is a web app. Gemini is a web app. Awesome engagement. That is correct. So those are good examples of web applications. So we will soon get to know the difference between the two. And then after applications, we then also have computers as a building block of the digital world. So when we are talking about computers, we are looking at the likes of our mobile phones. Our mobile phones are actually computers, tablets, e-readers, laptops, desktop, web servers, database servers. So those are examples of computers. So then we also need network. Network, I've already talked about the internet, which is an interconnection. Why are people not naming theirs? Why are people not naming theirs? How do you mean? They're not naming what? What theirs? Maybe you can explain hapo kwa chat tuambie, what do you mean they're not naming theirs? So network, you're talking about the internet, you're talking about wired networks, you're talking about wireless network. Wale watu wa Wi-Fi, mmemulikwa, nyinyi watu wa wireless network. Watu wa wired network na wale yenye tunatumia LAN cables, you have, is it LAN ama ni Ethernet cable? You connect maybe from your router to your machine. Lakini siku hizi lapi zenye zinatokea siku hizi, like even hii yangu haina hiyo port ya LAN, so hapa tuna choice, inabidi tufanye nini? Either can I buy a converter for it? No, I don't think so. Hii inatumia tu Wi-Fi. Wi-Fi still serves it serves well. It serves well. So the definition of the terms that we've discussed above tutapata huku chini, so msiwe na wasiwasi. So tumeingia kwa basic computing terminologies. So hapa kwa basic computing terminologies, when you are talking about an application, ni type C port. What is type C? An application is a computer program. That is how you define an application. Or if you want to beef up or to meet up that explanation, we patia more words. You can say an application is a set of instructions that runs on a computer to perform a specific task. So ukisikia mtu anazungumzia an app. So an app is simply a set of instructions which runs on a computer, enabling this computer to perform a specific task. Meaning that a computer without this set of instructions is just but a box. It can do nothing. So it awaits for instructions for it to be able to do something. So a computer program is written as code in a programming language. So another term that has been introduced upon is code. So the program that you write that enables applications to run is written using code, and that code is written in a programming language. The same way we speak different languages. Computer pia iko pia na lugha yenye inaelewa. There are those languages that you can write for computer to understand. When you're writing a program, you've heard people, if you've been around and you've seen some job descriptions, they say, I am a Python programmer, or I am a Java programmer, or I'm a PHP developer. You see, all that, or I am a Ruby on Rails developer, or a Ruby on Rails engineer, stuff like that. So those are programming languages. So you can write programs in different languages, and then when you give it to the computer will be able to interpret it and run it. So computer programs are generally called software. Now, once you've written a program, that program is what we call a software. It is software. So it is the same thing that we have been discussing hapo juu. Hapa chini, the speaker notes are actually the same. So no need to belabor that point. Let us zero in kidogo to applications and then just look at applications in some kidogo detail. So types of applications. Remember when we were talking about the examples and you guys gave us some examples. So applications run on different types of devices and are accessed in different ways. So an application is given a name based on where it runs. You see, if you have a web application, the way tulikuwa tumesema web applications, these ones run in a web server or application server, you know, and is accessed from a web browser. So you can access it via a web browser. I was telling my channel earlier that someone yesterday had chatted me on WhatsApp and was asking me, will the labs be able to run? Will the labs be able to run on his MacBook? Nikamwambia, the lab in themselves first, they are running on a platform called Vocarium inside Canvas. So it will be able to run because it's a web application. So it is not dependent on the underlying operating system that you have. You know, it's not dependent on the underlying operating system that you have. It will be able to run. And by the way, even as we go to the second one where we are talking about the mobile application, let me also remind you guys, especially those ones who have phones in class and you are not logged in via your machines for one reason or the other, you will not able to run the labs on a mobile application. For the simple reason, it is coded to be a web application. So hapa hakuna shortcut. You will need to find yourself a PC to be able to run the labs. So mobile application, this one runs in and is accessed from a mobile device. So a device such as yours, you are able to run the mobile application. And we spoke about, you saw the examples that guys gave us. And sometimes there is normally, how do you call it? Unaweza pata there's an application that is both a web app and is also a mobile app. A good example is Gmail. Gmail initially, before the smartphones, it was a web application, but right now you can actually download the Gmail app and run it as a mobile app. You know, you can run it as a mobile app. Then of course we have desktop applications. These ones run in and is accessed from a desktop computer. So these are things that you install in your machine. You see, things that you install in your machine. Someone give me an example of a desktop application that you know of. There's a specific one that I'm waiting for people to say. If you don't say it, then I'll know where computer times have changed. Desktop applications that you know of, any? I'm looking at the charts. What's up? Okay, now the difference here is the desktop application does not need internet to connect. MS Office is one of them. Microsoft 20-something. Why 20-something? Hadi kina 2010. Hey, watu wamekuja na ubaya. Okay. Any other? Python 3.4. Yeah, I think. Yeah. What do you use to listen to your VS Code? Yes. What do you use to watch your videos? Maybe you want to watch a movie. Mnatumianga player gani? Exactly, Justin. That's what I was waiting for. Kila mtu anatumia VLC. Hamna player ingine. There's no other player that you know of. Media Player, Media Player Classic is good, especially when you are playing something alafu uanze kuona it's like kuna scratches. Media Player Classic, sometimes when I clean that one out and it continues to play. VLC is very famous. I have seen. Awesome. Thank you for that. Thank you for that engagement. So those are desktop applications and those are the examples. Awesome, thank you. So next, we also have Internet of Things applications. This one runs in and is accessed from an appliance or specialized device that is connected to the internet. So this one runs in and is accessed from an appliance or specialized device that is connected to the internet. So we'll get to see all of this. So I think when I was looking at this notes, this one looked interesting. There are many different types of applications that exist. They can be differentiated based on what device they run on and how they are accessed. The following list contains some examples of different types of applications. So an example of web application, these are, number one is web application. This is anything that can be accessed through a web browser. We have the likes of Mozilla Firefox. Mozilla Firefox as an example of a browser. Example of web application is Amazon.com. Then we have mobile applications, Amazon Shopping mobile app, and your bank's mobile application. Those are examples of mobile apps together with the ones that we were told earlier by our friends. Then desktop application, we have word processors, we have web browsers, we have games, we have video editing software, we have programming tools. I saw Python 3 somewhere. We have VS Code, I saw it somewhere. So Internet of Things applications on a smartwatch or inside a smart refrigerator and a global positioning system, GPS navigation application in a car. Those are examples of IoT devices. Or applications. Yes. So when you look at your computer, na hapa sasa, I hope you guys have had an opportunity to see, to interact with to interact with a desktop computer. Hapa tuzungumzi laptop, although these things can also be bado pia kwa laptop, but I hope you guys have had an opportunity to interact with these things because you see them better in that context. You see them better in that context. Okay, you see them better in that context. So components inside a computer. So we have two components inside a computer. The components inside a computer, I think they are distinguished into two main ones. We have this hardware and the software. So when we are talking about hardware, here we talk about motherboard, the central processing unit, memory, storage device, and network card. We will get to know what each one of those does. But from the images, you can clearly see this is our power supply. This is our motherboard. This is the audio card. And you see it has the places where the jacks go in. Then we have the RAM modules, or RAM, what we call RAM. Then we have hard disk. Then we have the ports. The ports, this is where you will put your USBs. This is where you will put your flash disk. This is where you will connect your HDMI cables, your VGA cables, your display cables. And also, it also has places where you can connect the lights and output device, such as my headphone. And then we have the network card. This is for networking. Then you have the processor. And you have the solid state drive, SSD. So SSD and HDD, these ones are storage devices. And then, of course, you have some cables to connect. And then there is the CPU cooler. You know, CPU cooler, it helps to cool down the CPU because the CPU can get quite hot, especially when you're running heavy applications. Then we have video adapter. We have video adapter together with some cables down there. Then when it comes to software, we have operating systems. So the operating systems here, I know we've been given an example of Amazon Linux 2, but we have many other operating systems. We have Mac OS, we have Windows operating system, we have Linux operating system. There are so many. And when we talk about Linux as an operating system, it has many distributions. So we'll delve into those ones later. And then there are applications that you also get to install. The ones that we've talked about, there are those that you get to install in your machine. And even when you go to the cloud, you'll discover when we have an instance running, the EC2 instance, maybe running an Amazon Linux 2 operating system, we can now download some applications and put them and install them inside that EC2. So the EC2 is just like your computer. If you've never used cloud before, just think of it that way. The same way we are talking about these computers, these normal computers that we are talking about, the ones that we've discussed, the same way you would actually transfer that knowledge to the cloud. So many of these things will be abstracted for you. You'll not be able to interact with the motherboard, CPU. Okay, CPU and memory, there is a way that we will set them when we are setting up the instances. The memory, the storage capacity, and the networking, all that will be able to configure them in the cloud. It's such an interesting thing to do. I hope you guys are looking forward to that. And then there is the Amazon Shopping application, or Amazon Shopping app, as an example of an application that has been given. So again, a computer contains hardware and software. That when we've said, hardware refers to a computer's physical components. Something is physical and you can touch it. So that is physical components. So a CPU, you can touch a CPU and say this is a CPU. A computer fan, you can actually touch it. You see, so such as the CPU, as I've said, memory and storage drive and storage drives, those ones you can touch. Software is the collection of applications and processes that are installed on the computer. You cannot touch a software. You'll just know that this software is inside there. Fact that you can touch a disk, for example, that has Kaspersky as a malware intrusion, malware detection, or is it malware detection? Yeah, it's an antivirus, yes. Such as an antivirus does not mean that one qualifies to be a hardware. It is software, because what you really need to run is inside it. You know, so you run that, you install it, it protects you. So examples of software include operating systems, all the OSs that we've talked about, and an application such as the shopping app from Amazon and all the other applications that we have already given examples on pale kwa chat. So The following are the main hardware components inside a computer. These ones we've talked about: CPU, memory, storage drive, where we have the SSDs and the HDDs. SSD, I've shown you even the picture of it and the HDD. And then we have the network card. And then we've also talked about the software components, the OS applications, all that we've done. Yes, so we'll learn more about them. So I just want us to brush to Kisonganga. The motherboard holds all the core computer hardware components together. If you've ever taken your machine to a fundi and then seen it opened, you'll be able to see this motherboard. And then you'll be able to see, by the way, CPU imewekwa hapa, the processor iko hapa, so RAM iko hapa. And sometimes some devices even allow you to expand to expand the RAM. The RAM, random access memory. You can expand it. Maybe you bought it ikiwa 256. You can expand it even to 512 or even to a TB or something, depending on its ability to handle. Then there are those storage devices, the storage devices which we've talked about, SSDs, HDDs. And then there are those network card. The network card is what enables your computer to communicate with the internet and also to communicate internally with different components. Then we have the video card that makes it possible even for things to be displayed. And then we have the computer ports that you can connect the likes of these output devices, the output devices that you'd like to use. If you are like me who wants to use an external mouse, you can use a wired external mouse, or you can use one that is wireless. All that can be done using. It can be done, you can connect all that to your motherboard. So you can see the motherboard is very important. That's why when you take your machine to a fundi, and then the fundi tells you that your motherboard imechapa, that one know that the cost of repairing that motherboard will come very close to a cost of buying a new machine. So sometimes it's a matter of you kupiga hesabu and see and ask yourself, is it worth it to spend, like, let's say 20 Gs repairing this motherboard, or should I just add 5 Gs and get another machine? You see, stuff like that. So that motherboard, sometimes you call it a system board. So it is this motherboard that holds all those components that we've talked about together. I hope that is clear. And then now within the motherboard, there is a CPU, Central Processing Unit. So the CPU is not that, how do you call it? There is normally, if you're using a desktop machine, there's normally a box. Let me just call it a box. In many places, we've been calling that a CPU, but that is just a casing that actually has all of these things inside. But a CPU is actually a very small component of all of that, and it is normally on the motherboard. You see, it's normally on the motherboard. And the work of a CPU is the brain of your computer. Everything runs through the CPU. It is the CPU that actually powers most of the things that are happening. So it runs the instruction that it receives from applications and the OS. Some of these instructions are things like arithmetic and logical operations. For example, we do 1 + 1. The CPU will be able to run that and then give you an answer. It controls control and input or output operation. So if there are those things that you want to do, for example, I'm typing something on my machine and I want to see it displayed. That is the work of the CPU. It will make sure that whatever I have typed, it has been received and then it is displayed. Hiyo kazi ya CPU. So CPUs can have multiple cores, which increases their performance. So ukiangalia, when you look at your machine, there is a place that you can actually see how many cores your machine has. Like the machine that I'm currently using is a Core i7. So it means that it has those many cores. So the more the cores, the more power that machine has to do complex stuff. Like for my machine, I use it for coding, I use it for teaching, I use it for entertainment, I use it for many other things. And I can have multiple processes running together without having it overheat, or slow down. So cause that is something that can also guide you to know how your machine performs. And you will see when you'll be getting to the cloud, you will see that we can actually also set this in the cloud in terms of our servers. And then sometimes we also call, the CPUs are also referred to as processors. Why? Because you've seen everything that we've discussed. You have seen that it actually takes whatever you give it and gives you something out. So that is a process. It is the same as you taking unga to kisiagi, you take it to a kisiagi and then it comes out as flour. So that processing. So CPU, you will type in stuff, then the computer will translate it into zeros and ones, convert it. Okay, first of all, it converts it into its own language for it to understand. Once the processes understand it and the output is ready, it will convert it back to the language that you will understand as a human being. Imagine if you would have to read zeros and ones. You type zeros and ones here, you read zeros and ones, and then you have to make sense of it. That would have been very, very tedious. But that is possible for us, courtesy of the CPU. Memory, what does the memory do? So the memory holds program instructions and data for the CPU to run and use. You see, sometimes, like the example that I've given you with myself, I run multiple programs running concurrently. So these programs, for them to run without any problem, there needs to be the RAM where the instructions that I've given, say for program 1 is stored there, for program 2 is stored there, for program 3. So the CPU is able to pick these instructions and run them. So that's why we call it a random access memory. So anytime we are running, we are running programs on our machine, know that before they are processed by the CPU, there is the memory that holds them. Ni sawa na kusema the memory, the CPU is like a boss in an office, and then the memory is like a secretary in the waiting room, holding everything and then just allowing you to go in when it is needed. You allow it to go in when it is needed. So the CPU retrieves programs, instructions from memory. That's what it does. The CPU retrieves and stores programs, data in memory. So it can retrieve instructions from the memory, process them, and send them back to memory for storage, for temporary storage. Memory is temporary storage, and there's a reason why we call it memory. We call it temporary storage. Data is lost when the computer is turned off. An example, let's say, for example, right now, something happens and then my machine just goes off. And then I turn it back on. I'll have to start again, making sure that one, I am connected to the internet. I go to my email, click on the link, then come back here. Meaning that everything that I was doing prior to that interruption has been lost because that was temporary. That's how temporary it is. So when you come back, if you did not save what you are doing, let's say you are writing an article, if you did not save it and then it has been saved in permanent storage, then you'll have to come back and start again from the beginning. So that is how I would make sense of temporary storage. Then the size of memory is measured in megabytes. You've heard people talk about MBs of data, or heard someone say that my drive is this GBs big, or this program that I am downloading is this gigabytes big, So 1 megabyte, 1 MB equals to 1,000,000 bytes or characters, 1,000,000 bytes or characters. So that is just to mention, it is worth 1,000,000 bytes of character, 1,000,000 bytes or character. Then more memory equals to faster performance. So utaona, if you have a machine that has like 64 GB of RAM compared to someone that has a TB, a terabyte of RAM, of course, zimefika huko kweli. Let me use what's the biggest RAM currently? If anybody knows, maybe unaweza niandikia hapo kwa chat. Yeah, so simply put, what we are just trying to say, the more memory you have, the faster your machine will be. No. But again, don't just rush out there to pick a big RAM and then you are trying to bring it to a machine that is ya kitambo, a machine that is not able to handle that kind of RAM. There are many other factors that come together in order to boost the performance of your machine. To boost the performance of your machine. Ni sana kwenda kusema you want to take like engine kubwa, a big engine, and bring it to Avits. Bring it to Avits and then expect it to perform at that level, So it's always important to make sure that you match up all the other things. So Memory is called random access memory. This memory that you're talking about here is called random access memory, and we've talked about it. And these explainer notes here are for your own consumption, and they're just saying the same things that I've just told you, so no need to read through it. When you are looking at the storage devices, there are two types of storage devices. So a storage drive, or rather, a storage drive stores program files, application data, and user documents. So the user documents are the likes of your Word documents, your PowerPoint presentations, your Excel sheets, any document that you have created, including Atakamani images, all that. It is stored in your storage drive. The following are two popular types of storage drives. So we have the hard disk drive, or the HDD, and the solid state drive, or the SSD, HDD or the SSD. Most machines zenye zinakuwa produced siku hizi actually come with SSD as the storage device. So as the storage drive. So drive storage is persistent, meaning that it is permanent. And if your machine goes off, whatever you stored in these drives will be saved. It will still be there when you power back your machine. So the data is preserved and the computer is turned off. Drive performance is measured by its data access speed. This is how we measure drive performance, MB per second. MB per second. So your drive, if your drive is able to perform higher at these stages, then it means that all the other things can work faster. Remember what we said? We say that all of these devices that you're talking about, all of these components need to work together for your machine to be able to perform well. So we also have number of IO operations per seconds. Those are what we call IOPS, input and output operations per seconds, IOPS, number of IOPS, you see. So that's how we are able to measure data access. And you'll be seeing this when you go to the cloud. There are some specific servers that are actually, how do you put it? That they are actually optimized. They are optimized for storage. They are optimized for storage, and there are others that are optimized for compute. There are others that are optimized for different things, depending with what you want to do, what your workloads are doing in the cloud. So you choose an instance or a server that has exactly what you are looking for, So that is that. Then computer networks. Now, as I've just promised, we'll be talking about networking later, but here we're just doing a high-level introduction. So a computer network connects multiple devices to share data and resources. Connected devices can be of different types. You can have computers, printers, storage drives, and smartphones. The following are types of networks. We have wired, where you connect using an Ethernet cable, and you have wireless devices, which are connected by using a Wi-Fi signal. They are connected using a Wi-Fi signal. The internet is the largest and most popular computer network. I mentioned this when we started. It's just an interconnection of devices from different parts of the globe together in a big, giant network. Now, when you start thinking about a network, think of it this way. Maybe look at where you are right now. Maybe you are in your house. Maybe, I'm just assuming, or you are even in your home. Now, when you look at it, you can see that you have a router that is receiving internet from your internet service provider, and then this internet is distributed within a certain radius where there are different devices that receive internet from this. Maybe you have your smart TV that is connected using an Ethernet cable. You have a number of smart devices such as your smartphone, other smartphones, tablets, all of this connected to this same network. They are all connected to this network. So you have just built your own home network, with that router and all these other devices connected to it. So that is what we call a network. So an application that runs on a given computer might interact with the other applications that run on different computers to access information and complete its function. For example, mobile apps often communicate with other applications that run on a web server to get data. You see, that to get data. These different computers can use a computer network to connect and communicate with each other. In a wired network, computers use wires, typically Ethernet cables, to connect to a router. That's in a wired network. In a wireless network, computers connect to a router by using the router's Wi-Fi signal. You will learn more about routers later in the course. Yes, when we'll be doing networking, I believe. Then there is this other component that we call the network interface card. A network interface card connects a computer to a computer network. It takes a computer and connects it to a computer network. So a computer uses it to communicate over a network, such as the internet. So the internet is one of the networks through which a computer can communicate. Then different types of network cards provide wired or wireless connection options. The speed of a network card is measured in gigabits, not gigabytes, gigabits per second, GBps. It's also called a network adapter. So ukiambiwa my machine has a problem, you go to a fundi and then the fundi tells you it's your network adapter and imechapa. That is why you're not able to what? You're not able to connect to the internet. So all that is possible. You can do all that when you have a network interface card, and it is replaceable if ikichapa kwa machine yako. So the same thing has been explained there. Then the operating system, an OS. What is an OS? An OS manages a computer's hardware and software. An OS shares and coordinates the use of CPU, memory, storage, and network by application. An OS provides the user interface. Yes, whatever you're able to see, what you're seeing right now. This is what we call the graphical user interface. Awesome. Thank you for that, Leonard. So Leonard is telling us that we have machines that have amazing RAM. Hey, but the thing is Bay, like that ThinkStation P8, Lenovo ThinkStation P8. My machine is Lenovo X1 Carbon. Mine is Lenovo X1 Carbon. But now that ThinkStation P8, do you have an idea how much it is? Maybe maybe there is someone who is shopping for a powerful machine. And that's very nice. Thank you for sharing. So we already have machines that have up to 1 TB of RAM in the market. That is crazy. That is awesome. Powerful machine. So we were saying that an OS provides the user interface. So there are two types of interfaces that you can get. One is a graphical user interface. A graphical user interface is what you are seeing. Daniel, 4GB. Okay. So a graphical user interface is what you are seeing, where you can actually click stuff and have them run. That's a graphical user interface. Then a command line interface is where now you get to interact with something like this. Let me just show you. I think it makes sense showing. Let me just show you. Ati 4 zote. Kwani yako ni ndogo aje, Justin? So let me just see. Mashini imesikia nataka kuonyeshana CLI yangu alafu ikaamua itulie. Okay, we will see it when we go to the labs. But actually the command line interface is something that you can also use to interact with your computer and the different components. Then these are some examples of operating systems, the ones that we had talked about. So we have Microsoft Windows, we have Mac OS, we have Amazon Linux 2, we have iOS, we have Google Android, and when it comes to Linux, know that Linux comes in different distributions. So the one that I use is Ubuntu. I use Ubuntu. So for pen testers and ethical hackers, there is Kali Linux. There are the likes of Akina Fedora. There are other distributions. So many. Time will run out on us just mentioning those distributions. Yeah. So an OS manages a computer. Just a second. So an OS manages a computer's hardware and software. You can use it to interact with your computer. Some applications work only on specific operating systems. So you need to note that. There are some applications that will only run on Windows. Although Squeezy, there is a way that you can make some of these applications also run on Linux, but they were built or written for Windows. Things like Microsoft Word, for example. Things like Microsoft Word, maybe that is supposed to be running on Windows, but someone told me, I don't know, you can use Wine or something and have it run on Linux. I'm yet to try it. So it's possible that you come across that. Now we have come to the end of this unit. It was short and sweet. So here are some key takeaways. Number one, for me to also get a breather, who can unmute and read for us these key takeaways? Someone? No need to raise your hand, just unmute.
Applications, computers, and networks run the digital world. An application is a computer program. It is a set of instructions that a computer runs to perform a specific task. A computer's hardware consists of its physical components, such as its CPU, memory, storage drive, and network card. A computer software consists of programs that run on it, such as its OS and user application.
Awesome, awesome, awesome. That is that is very nice. I hope you guys have seen that. And so those speaker notes are just the same. And thank you all for that. So I'm giving you like a minute just to breathe and take that one in before we move on. Before we move on. I'm just giving you a second. Oh, wine made you return to Windows. Wine is too complicated. I don't recommend it at all. It has a failure rate of above 70%. So for me, I think my solution was my solution has been to I decided to make my machine dual boot. Dual boot, it means that I have Linux installed, and I also have Windows installed. So when I want to do my development work, I just shift and go to, yes, it needs a large RAM. So I did not want to brag, but you can almost tell my machine has some good some good RAM. No, it is not slow at all. It is not slow. Hata kidogo, it's not slow. That WSL thing also showed me things. I did not like it. I did not like WSL. I did not like the WSL. Oh, so Justin anasema don't dual boot for a machine that is below 16 GB. Yeah. Yes. Yes, it is way above it. Way above it. Tuko pale kwa 4 GB kama Daniel. Tuko pale kwa 4 GB. Watu wa 4 GB. So, yes, it's 16. Awesome. Is it dual boot? No, it's not. Okay. 16 GB RAM. But I think I need to check the RAM. My RAM though nisikuwe nawauzia hewa. Let me see system properties. Where? But then my RAM is not big. My RAM is not big. It is, I said it is way above. I lied. Sorry, it was not intentional, but let me just drag this here so that you can see. This is actually my machine. You see, 8 GB. And I have dual core and it's running. I assure you it's running, and it does not hammer. You see my storage? You see? Yeah. Ama you will say that something compensates upper. Because it's okay. The fundi told me it's a Core i7, so I believed him. This is a Lenovo ThinkPad. But you know, again, Lenovo in itself zilitengenezewa developers and gamers. So that aside, I hope you guys have taken a minute. Kama ni kukimbilia maji, umechukua maji, ukunywe maji. Ukifeel umechoka unaweza lamba glucose. Vile tuliambiwa na Joy, unalamba glucose na tunaendelea. So right now, what is COD? Range, what is COD? Those, unaona Nicodemus pia akona 8 GB RAM dual boot. Tuambie COD ni nini Riju, situache tu hivyo. Pia sisi tukuwe na kitu ya kubrag tunajua leo. So you're just joking with us. Oh, hii ukiweka COD Call of Duty itapumua gani hiyo yangu ya nini ama ya deno ya 4GB. So as we continue, I want you guys to take note of the following. We are not going to go into breakout sessions today. We are not going to go into breakout sessions because there is no lab that you are going to do. We will not be doing a lab today. So the KC that we'll be doing, we'll do it as a joint class. And I am saying this because I want you guys, especially when you have a machine, if you have your machine with you, please make sure that you have logged into Canvas. Remember what I told you guys in the morning. We want you guys to do the cases together. We want to do the cases together. So looking at time, it is 3:04. So I want us to do the cases. I want us to do the first KC for the unit that we've just finished. And we are going to do the cases together. I hope that's okay with you. Both Kenais, we are doing the cases here in class. You will not be going for a breakout session in this afternoon class. So that was introduction to computing. First of all, by show of hand, how many of you have logged into Canvas? Because I want us to go together. Nataka by the end of the day today, everybody mkuwe tayari ingia Canvas. Tumefanya the cases. It's important. I'm waiting to see your hand up. Please, if you have logged into Canvas, please raise your hand. And it is for your benefit that we do these things together, because you don't want them to pile. They can get quite something. Anthony, Belinda, and where possible, guys, try and make it a habit to always log into your Canvas and then join the meeting with your PCs. It makes work very, very easy. Chelsea, Guile, guys, let us join. Let us make sure that we are on Canvas. Raise your hand and keep it raised so that I know who is yet to get there. Because when I start the KC, I want us to move together. What has happened? Okay, it's back. My screen had gone blank for a minute. Okay. I'm still waiting. And who is this 23/03340? You are requested to change your what do you call it? You are requested to change your username. Actually, to edit your name to your full official names. Also, HR reception. You are still joining with HR reception. Man. When we mark you absent because we did not see your name, then you'll end up blaming us, yet it's not our fault. Okay, So this is what you are going to do. I'll just proceed and then we will do, I'll just proceed with those who are already logged in. It is to their benefit and it will be unfair. It will be unfair to deny them an opportunity to have their cases done, to do their cases now. So give me a second. My screen has gone blank again. Okay, sorry for that. Just a second, let me just get something here. What's up? Okay, thank you. Thank you for guys that have raised their hands. I can see like 32 of you have your hands raised. So 32 is a good number to start the cases with. For the rest, we will find a way of helping you also to make sure that you are done with your KC today. Please, 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 we kindly request that you don't let these things pile up. You'll not be able to do all of them. So guys, you can unraise your hands. Thank you. You can unraise your hands. Can raise your hands. Just give me a second. I get something that you're going to use to do the cases. So if you are on Canvas, that's instructor. I need the one for student. So if you're on Canvas, you will be able to see this KC Introduction to Cloud Computing. Okay, KC Introduction to Cloud Computing. So this is what we want to do just now. Just a second. Introduction to Cloud Computing. So when you click that, there's this instruction, load this in a new window. Click on that. Continue. And then it will bring you to this place here. Cloud Foundations, Introduction to Cloud Computing. If you can see that, let me see some thumbs up. And then everybody whose hands are raised, please unraise them. We are done with what I was looking for. So unraise your hands. Basil, unraise your hand. Thumbs up is not raising your hand. Thumbs up ni, there is that thing. Yes, kama yenye guy lameka. That's a thumbs up. So we will do this KC together. And one thing I told you guys about the KCs, when you're doing the KCs, you have the liberty of doing the KC as many times as you want and always strive to score the highest marks, okay? Strive to score the highest marks. That is very, very important because you need to do all cases and you need to score an average of 70 in all of them for you to graduate. So it is a very important thing. That's why we insist on doing them together in class. That's why we insist on doing them together in class. So the KC that we're going to do is on Cloud Foundations. And for the first time that we are going to do it, we'll just do it together as a class. And here, oh man, something is happening to my screen. I'm getting dark screens. Just a second. Let me sort it. Let me sort it. I guess it's back. Yes, it is back and it's still recording. Okay. So we are going to do this KC. And the way to do your KC is that first of all, you click on it, you open it in a new window, and then you click on start and you'll be able to start the KC. You'll be able to start the KC. So let us do this KC together. Let's do this KC together. This is Cloud Foundation Introduction to Cloud Computing Knowledge Check. So we are checking knowledge based on what we have learned in class. And here I will need you to raise your hand and give me the answer because you are doing them together. Maybe what you can do before you start answering them on your end, you can write the answers down. If you have a place to write, you can write the answers down. So let us start with our cases. We have a total of 5 questions. So let's do them together. Number 1, what is a computer program? a device that is connected to the internet, a set of instructions that tells the system how to perform a specific task, an interface for interacting with the device, such as a laptop or a mobile phone, or a document that describes how to build a software. Who wants to answer? Give us an answer.
A set of instructions.
A set of
the second one.
instructions. You are sure?
Yes.
Who is that? Who is that? I can't see you. I see Kwani screen. Just tell me your first name and then answer. So what is your name?
My name is Brian Mahali.
Brian. Brian, prepare yourself for virtual Ngotos if you get it wrong. Okay, let's see. Let's see. 1, 2. He's got it right. So makofi kwake, that is very good. So that is the answer for question 1. I hope you guys have captured it. Question 2. What is the role of the motherboard in a computer? What is the role of the motherboard in a computer system? Runs a set of instructions, stores data, connects all components, displays information on the screen. What is the answer? C. Connects all components, yeah? Okay, let's submit. That is correct. Good. Thank you. Which components are a physical part of a computer system? Select 2. So which one and which one?
Motherboard and network card.
Motherboard and network card.
Yes.
Not the OS.
No. It's an application.
No. Network card and motherboard.
Nilikuwa nafikiria nataka kukataa those answers. Let us see. Let us see. That is correct. That is correct. Awesome. Then, which statements describe random access memory? Select 2. Which statement describes random access memory? Select 2.
It holds data temporarily.
It does what? It holds data persist.
D. Yeah.
D.
Temporarily.
Oh,
Yes.
C. A, B, C, D. Okay,
D.
this one. Another one.
And it can
be accessed quickly.
Are you sure?
Yes.
It can be accessed quickly.
Yes.
So these are the answers.
No.
Uh-huh.
It can be a hard disk drive or a solid state. So it's
No.
C and D.
RAM. Remember, questions, you look at the keywords. Look at the keyword in the question. Which statement describes random access memory? A and D. Those are correct. Sawa Ridge, tukipata tumedunda. It's correct. Awesome. Thank you. That was good. Last question. Which of the following are examples of operating system? Which of the following are examples of operating system? Select 2.
iOS.
And?
I think Amazon Linux 2.
Amazon
Linux 2.
Amazon Linux.
Amazon Linux.
Amjaanza kufanya Amazon Linux, lakini tayari mmeshajua ni operating system. That is good because it was part of our notes. That's very good and that is correct. You see, so that's what you do, and this is what we would like to see you guys get. Forget about that. This is what we'd like to see you guys get. Try and strive for 100%. So if you have done and then you find that maybe your scores are not there, they're not that high, you can you can redo it. You can redo it until time that you get this kind of scores. So I hope that was fun. So We'll be looking at the back office just to see, to make sure that you guys have done the cases. You can close the window once done. Yes, you can close the window once done. You can close the window once done. So, we are going to, because these are not very heavy stuff that we are doing, we are just going to go straight into basic computing concepts. I hope you guys are good. Ahmad, do we have any questions? Silence means no questions. So I'll just shift over and go to basic computing. And this one, we are going to also brush through it because it does not have really a lot. There's nothing difficult that you're going to encounter. So these are the objectives for this next unit. You will learn how to do the following: describe servers and data centers, discuss computing technology that makes cloud computing possible, and then describe how software is developed. How software is developed. So that is what you're going to be talking about. And we are going to start from servers and data centers. So what is a server? A server is a computer that provides data or services to other computers. So a server is simply a computer that is able to provide services and data to other computers. A server provides a response to a request from a client computer over a network. The way I'd like to visualize this, I will say, when I go to google.com and then I search, for example, I search for a tutorial, that request that I've sent, it will be received, and then the computer, now huko nyuma, it will now go and look at a different, it will take my request over the network, go to different servers, and look for a response from different databases and then bring it back to me. So whatever I send out is what we call a request, and whatever I get back is what we call a response. Server hardware typically differs from a desktop hardware to support the following. A server hardware requires more memory and multiple CPUs because it is serving other computers. It requires redundant power supplies and network interfaces. And you'll see this a lot when we start talking about data centers that are run by the likes of AWS. Then it also has a small form factor, and you can see an example on what I'm pointing here. You see, this is an example of a server. You can see it is actually very, 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 very small, but it has everything that we discussed that a computer has. This thing has it, and it has many of them. Then examples of servers include the following. We have a web server, a database server, and a mail server. And we will get to know the difference between these three types of servers in a bit, Like, for example, there are many different types of servers. Like we've said, there's this web server, which is used by web applications to serve hypertext markup language or HTML pages to a requesting client. So an example of what I told you that I'm looking for this tutorial, what I get back, it might be an HTML page. Maybe there's a tutorial that takes me to FreeCodeCamp, for example. So I will get a response. And then we have a database server that hosts database software that application used to store and retrieve data. So data is stored, that data can be stored and retrieved from a database server. And you will see this one's also in the cloud. Then there's a mail server that is used to send and receive email from and to clients, from and to clients. So this picture here is quite interesting because it summarizes what we've just talked about. Client and server example web application. Client and server example web application. Sorry, oh. Babe. Oh, Jesus, what has happened to my machine?
Guys, let's give our instructor some few minutes. I think he's having some challenges with the internet. We give us some few minutes. Sorry for that. Welcome, guys. I hope you're all in here present. Patrick, you can take it up.
Awesome. Thank you, Esther. Thank you so much. Sorry, guys. My machine did that thing. It just went off, and we were just talking about what machines can do. So sorry for that. I hope our train of thought was not interrupted, Sana, so we can pick it up from where we left. So I believe that I was talking about this diagram here. Kwanza, Ebu, confirm to me if you can see my screen.
Yes.
Okay, thank you. So client and server examples, web application. I remember having told you that when a client sends requests from a web application, let's say, for example, that is a website that you'd like to visit, it travels over the internet and it goes to a web application server. That web application server directs the request to a web application. So the request to a web application, and the web application accesses the application data that is now stored where? In a database server. So from the database server, you're now able to get your response retrieved from that database server. And then that database server returns the application data through the web server. And then the web server returns an application page back to the browser client. And if you had requested for that website, you'll now be able to see it. So that is how traffic flows in terms of request and response. So that is how it works. So here we have an explanation. This one you'll take time and read it, but let me just read through it real quick. Running a web application is an example use case for servers. A web application is typically deployed to a web server, which is responsible for directing client requests to it. A web application usually stores its application data on a database server. Hi to you. So, was it me, the Patrick, or another Patrick? But hi.
Oh, sorry,
Okay.
sorry for that. My kid has just.
Those are kids. We understand. That's a future cloud engineer. Very nice. Very nice. So, msalimia sana. So we are talking about the DBS, database management service controls the organization, security, and access of the data. Example of database management services are the likes of, or systems are the like of MySQL, an open source relational database management system. And these things, you'll see them in demonstration as they work in the cloud. You'll see, we'll do that. We have Oracle, a relational database management system that Oracle Corporation owns and offers. Then the following list shows the flow of information. is happening? Well, okay, I am back again. Today seems like I'll apologize a lot again. I'm sorry for that. So let me just share my screen. These are the challenges that we get, but I hope you guys can still see me. Give me just a second. I share my screen. I'll solve those issues once you're done with the class. Starting tomorrow, the classes will be flowing nicely bila shida yoyote. So I'm sharing my screen. Again, Esther, kindly give me the screen sharing rights. I'm still waiting for the screen sharing rights. Okay. Still waiting for the screen sharing rights. Mhm. We are waiting for screen sharing rights. Just give it a second. Actually, the second interruption was something different. Daniel, please mute yourself. Mhm. Bila those interruptions right now, we will almost be done. Sorry for that. Let me just see. Mm. Mhm. Okay. So give me a second. Guys, again, I'm sorry, just give me a second. Let me try and figure out this hosting thingy. I need rights to be able to share my screen. So I'm waiting for Esther to assign them. Give me a second. Let's just be patient kidogo. So I have a question for us. I have a question for us. As we are waiting for me to be assigned the, again, sorry, for me to be assigned the screen sharing rights, can we just continue with the notes? Can we continue with the class? Are you guys on Canvas and can you see the notes? I must share my screen for you to follow the notes. What do you think?
Patrick,
Yes.
check now. If it's not possible, I can share for you my screen.
Okay, please share for me. Still, I can't.
All right.
Okay. Thank you, Joy. Okay, just give it a second. Joy is going to share the screen for us, then you can proceed. So Nona, when you are kicked out of the meeting.
Patrick, you can now share the screen.
Okay. So I was telling you guys, when you're kicked out of the meeting, now I understand what happens. So Poleni for that. Now I think we can proceed. Give me a second. Okay, so which screen are we sharing? This one. Okay, so again, via thumbs up, confirm to me if you can see the screen. We are back. Good, thank you. Okay, so I had already discussed this, and we are talking about the flow of traffic right from the time you request something from, say, the database. Oh boy, my camera needs to be on. There it goes. So this is how the flow of traffic works. So when you first of all request something from our website, it goes into that machine, into the web server, then the web server to the database server. From the database server, you get your response coming all the way back to you. So that is what is explained here. And that when you'll get time to interact with that when you're doing your notes. So where does a server reside? A server resides in a data center. You've heard of people talk about data centers, and AWS also has its own data centers. There are a number of data centers spread all over different places for the sake of making sure that data is not just placed in one place, just in case there is a system, there is some system downtime, maybe due to man-made or natural calamities. So they make sure that these data centers are in different places. Here in the country, we also have organizations that also have their data centers in different places, private data centers, and we also have organizations that have specialized in offering cloud services or data center services to other organizations. One local cloud provider in the country is called Angani. Angani has its data centers in different places, and then there are also other data centers. So maybe one day you'll get an opportunity to visit a data center to see how it looks like and what runs there. So a data center hosts all of an organization's computers and networking equipment, including the following: servers, storage devices, network devices such as routers, switches, and hubs, and cooling equipment, and uninterrupted power supply. So those are some of the things that you can get in a data center. So it has all of that. The same things that we talked about when we talked about a normal computer. We said it has a storage device, it has a network device, it has a cooling equipment, and then we also saw that it has a power cable. Now for data centers, it's different. They have UPS, which is uninterrupted, in order to make sure that power continues, because they do a lot. So this speaker notes down here just explains the same thing that we talked about. We are saying data centers are designed to be secure and to provide an ideal climate for contained equipment to operate. Ideal climate in terms of the temperatures, shielding from weather elements, all that is factored in these data centers, and they must protect the equipment from many types of failures and accidents, including power loss and fire. So one day when you get an opportunity to visit a data center, you'll be able to see all of these things that we are talking about in class. So big question here: who owns the data center? So we have two models. We have the traditional on-prem model and the cloud model. For the traditional on-prem model, it is you who owns it. Let's say you are an organization, you own it because it's yours. You buy, install, configure, and manage all hardware and software in your own facility. And then you hire staff who are responsible for managing and maintaining the data center, including security personnel that make sure that access to it is also restricted. And you use your own data center resources. Yeah, you use your own data center resources. But now when you go to the cloud, a cloud service provider such as AWS owns the data center. The cloud services provider buys the hardware and infrastructure software for its own facility. So you are someone that wants to use the cloud, you will not have to buy those. Then the cloud service provider hires the personnel to support the data center. You know, so like the ones that we were talking about in the morning when we were talking about the data roles, when we told you that there are guys who worked as cloud support engineers. Those are just part of those people who work for AWS, and they work in this. They work to make sure that the data center works as it's supposed to work. And then you use the cloud service providers data center resources. So you are paying to use. So this is a paying model where you only pay for the resources that you'd like to use. So instead of you having to go into the trouble of installing, configuring, managing, hiring, all that, AWS and other cloud providers takes care of that for you. And then you only pay for what you want to use. Okay, you only pay for what you want to use. So that is explained here exactly word for what I've just told you. So no need to actually rehash that. Then we proceed and look at virtual machines. So when we are talking about virtual machines, what is a virtual machine? A virtual machine is a software-based computer. I remember when we were talking about the components of a computer, someone told me, when we were answering the KC, someone told me that, no, that is not a hardware, that is software. So yes, so here now we are talking about a virtual machine being a software-based computer. It is a computer, but it is now software-based. Like what you can see here, we have a physical computer, of which within it you have your virtual machine, and we can have your virtual machine 1 as Linux and virtual machine 2 as Windows. Those are operating systems, and they sit on top of a hypervisor, and below it there is the host. So the host is your computer, then the hypervisor is what makes it possible for you to actually provision those virtual machines on top within your computer. So a virtual machine runs on a physical computer, which is called a host, as you've seen. A software layer, which is called a hypervisor, provides access to the resources of the physical computer, such as CPU, memory, disk, and network, and we've discussed those, to the VM. So the VM runs its own operating system. You see, as you've seen, VM1 runs Linux, VM2 runs Windows, with the host and interacts with the host through the hypervisor. And then you can have multiple virtual machines, which can be provisioned on a single host. So virtualization. Virtualization gives you the ability to create multiple virtual machines, each with its own operating system and applications on a single physical machine. You see, so that is what virtualization helps you do. It gives you the power to create multiple VMs, each with its own operating system and applications on a single physical machine. This question is very, very important. Actually, this definition is very important because sometimes you go to an interview, then you are told, can you distinguish between containerization and virtualization? We'll talk about containerization at another time, but at this time, just understand what virtualization does and how it works. You see, it gives you the power to create multiple VMs, each with its own operating system, and is now able to talk to the host through the hypervisor. So again, this has been explained here word for word, like the hypervisor shares the host physical resources, such as its CPU, memory, disk, and networking capabilities among the VMs that run on the host. So a VM can run its own operating system, and multiple VMs can run on a single host. With virtualization, you can separate your operating system and applications from the computer's hardware. Use cases for VMs include virtual desktops, multiple operating support, and cloud computing. So we'll get to see this in practice when we now get our hands into our way into the cloud. Yes, into the cloud. Benefits of virtual machines. So there are like 3 main benefits. So one is cost saving, another one is efficiency, and the third one is reusability and portability. So when you talk about cost saving, what do we mean? We mean that here you're able to run multiple VMs on a single physical machine, which reduces the need to buy a new computer. So you have, like, for example, I have this computer, it is a Windows machine, and then I download something like an Oracle VirtualBox, okay? Then I use it to provision virtual machines inside it. So I have a number of virtual machines. I can have a Kali Linux virtual machine in there. I can have a Linux. I can even have another Windows inside there. And then now, instead of me buying 3 different machines, I have 3 machines running within my main machine. You see, so that one, what does it do? It saves me on cost. So if I wanted to do something, let's say, for example, I'm a pen tester and I want to see how these different things work, or I'm a network engineer and I want to see how these different machines can communicate to each other, I can build a simple home lab using that. So that is cost saving. Efficiency. Running multiple VMs on a single physical computer increases its utilization. Yes, because you find that there are those powerful machines that once you're able to build those VMs on it, they will share the underlying resources, the RAM, the CPU, the memory, all of that will be shared with these VMs. So again, know that this can be limiting because the maximum number of VMs that you can create is dependent also on the underlying infrastructure that you have, what your physical computer really has. To come at Dennis, if your 4 GB was true, then I really wonder how many VMs you can do with that. But again, you told us that it was just a lol. So it was just a joke. So thirdly, we are looking at reusability and portability. So when you talk about reusability and portability, we say you can copy a VM image on the same physical host or move it to a different host to duplicate the VM's computing environment. Yes. So that VM image that you have downloaded, because we normally download these VM images, you can actually carry it and take it to a different machine and still run it there and it will still run. You see, so that is very nice. And when you get to read your notes after class, you will see that everything that we have discussed above in an abridged way is actually expounded down here, like this reusability and portability. A virtual machine image defines all of the configuration, software, and applications that are installed in a VM. You can duplicate a virtual machine image on one or more physical hosts without creating a new virtual machine from scratch. And we have said that. This duplication promotes reusability and portability. For example, creating multiple copies of the same virtual machine to respond to incoming requests can improve your application performance when the number of requests increase. You can also copy a virtual machine image to a different host for backup purposes. So these things, I think you will see them very, very well when you start going to the cloud, because this course is all about cloud computing. But now when you go to the cloud, you'll be able to see how these things work in practice. So VM in the cloud, this is an example of what you are shown, how a VM looks in the cloud. And a VM in the cloud, you see we have our Amazon Machine Image, AMI, and then we have Amazon Elastic Compute Cloud, that is our EC2 instance. Then we launch an instance from that image. So the VM image is what we use to launch an instance, or what you can say we are provisioning an instance. So VMs are the fundamental unit of computing in the cloud. Virtual machines are the fundamental unit of computing in the cloud. And what these VMs provide include self-service, ability to pay only for what you use, and scalability. What is scalability? Scalability means that if your demand increases, and you need more machines, you can spin up more machines, or you can provision more machines with the same settings as your original machine. That's why we were talking about ability to actually, let me not say clone, but actually the ability for us to create multiple copies of the same VM. I hope that makes sense. So AMI is our hypervisor in this case, more or less, but not really. The AMI is like an image that you will use, like when we'll be doing a lab. I think we'll be doing those labs from tomorrow, and you'll be doing the lab. You will get that distinction very clearly, because an AMI, you choose the operating system upon which you want to build that AMI. In which you want to base that AMI on. It can either be Linux, it can be Windows. There are several, and you will see all of them tomorrow. For those who got an opportunity to look at the sandbox earlier today, you must have seen we showed you the console, and at some point for 153 I showed you that this is where you go if you want to create an instance, but you did not go past that. So when we start doing those labs, you will get that distinction very, very clearly. So software development lifecycle. Software development lifecycle. Software development lifecycle is normally abbreviated as SDLC. So software development lifecycle, it shows you the journey through. It actually starts from a thought, which is planned. After it has been planned, it is analyzed, it's designed, it's developed, it's tested, it's implemented and maintained. So any software that you see today, even let me use an example of VLC. VLC was first a thought by somebody who sat down with a team and they planned it. And after they planned it, where we say planned is what is the problem and what resources do you need to solve it? Like you look at a problem, every software that is developed, remembering the, how do you call it? Leadership principles from Amazon. They said you always start with the customer in mind. Ask yourself what pain point exists. That pain point, when you're bringing your software to the market, you have to ask yourself what problem is it coming to solve. You don't just create software for the hang of it. And then you ask yourself, what resources do you need in order to build that software? Those resources can be human resource. Maybe you need developers, you need DevOps engineers, you need QAs, you need all those guys that we discussed in the roles. Then you analyze, what do you want from a solution? This solution, yes, it is VLC. We have planned it. This is the problem that it is going to solve. Now, what do you want from this solution? You want it to be able to do A, B, C, D. Then you design it. How will you build what you want? Here is where now you start talking about maybe which tech stack am I going to use? Am I going to write it in this language or this other language? Remember also we talked about the programming languages. Which language is appropriate for this? You see, then you now sit down with your developers and you start building what you designed with the tools that you have chosen. Once you have built, then it needs to be tested to ask yourself, this is what we planned, this is what we designed. Now, what we have developed, does it check all the boxes with what we had planned and what we had designed? If yes, you move on to testing. You move on to implementing. You now take what you have built, you can bring it to the market either as a minimum viable product, MVP, or you can bring it out as a full-fledged software that is now ready to hit the market. Then now you maintain it. By maintaining, I hope you guys have seen that over the time, get updates. You get updates. You are told that version this of this has been released. Those versions are one, meant to seal any loopholes that have been found in the software, or two, they are also meant to introduce some improvements. Software devs in the house, you understand what I'm talking about. But even new people, you have seen even your own phone. Sometimes there are those applications that you've downloaded and then you're asked to update it. So update, that is the work. That is what we call maintenance, maintaining what you have already installed. So that is the software development lifecycle in a nutshell. And I'd like to invite you to interact with these detailed notes when you sit down, going just through what we have discussed. Now, the SDLC, you can see we are talking about the planning phase. I think I've summarized it up there, so I will also go through this just to get you in the flow. The goal of the project are identified along with the resources that are required to implement them. The output of this phase is a project plan. I remember when I was talking to my guys today about development plan, about the development roles, we talked about the project manager. And now this is where a project manager will be very strong, because they need now to come up with that project plan, so that now when you move on to the developers and those other guys that are coming in, they know what they are doing, because they have something that is guiding them called a plan. So many factors are taken into account at this stage, including economic, operational, and technical aspects of project implementation. So economical, you ask yourself, do we have the funds to do this? Operational, do we have what it takes to do this? Technical aspect, do we have the capacity in terms of our skill set to do this? Then planning for quality assurance also happens at this stage. It's always important to have QA in mind right from the get-go. And actually right now what we have done, even it happens in many software development places, they have now shifted security to the left. By shifting security to the left, it means even in the planning phase, you think about security. You think about security. Not long ago, the CTO for Amazon was in Kenya, and when we sat down with him in one of these meetings, he told us this. He told us that even Amazon itself, big as it is, it always thinks of security before a single line of code is written. And I think that's a very good guardrail because it ensures that everybody is aligned in terms of the importance of being security focused when you are developing an application. So regardless of the role that you decide to, of the path that you decide to take in the cloud, always know that security is something that you'll have to interact with at some point, and you have to be security focused and security minded in everything that you do as a dev or as any person that will be working in the cloud. So again, we now move to the analysis phase. The product requirements are clearly defined and documented in a software requirement specification, SRS. When you sit down with a client who wants you to develop an application for them, after you have heard of their vision, you're now supposed to sit down and now write an SRS. You've already considered the economical, you've considered the technical and the operational feasibility of the project that they have in mind. Now you've written this SRS. The customer can then approve the requirements. If they approve it because it aligns with their vision, or you have convinced them that what you wanted is this, but we think this is what is possible, this is what is feasible. Then once they have approved, an SRS is used as a reference tool at every subsequent step. Every subsequent step of the SDLC. That is very, very important to note. Then now you move to the design phase. Using the SRS, as you've said, it is used in every subsequent step. Different types of architectures are evaluated for the best use of the project. Different types of what? Architectures are evaluated for the best use of the project. More than one design approach is created and proposed in a design specification document, the DSD, design specification document. So you see now this is like another document that you're now coming up with. So even if you want to become a solutions architect, and I like what Joy told us in the morning session, that understanding software engineering is important for anybody that wants to work in any role in the cloud, because these things that you're going to deploy even as a DevOps engineer, there are actually applications that you need to understand how they work. You need to understand. And sometimes you will come and find that someone gives you an application to deploy, but you'll have to sit down first of all and go through these documentations that we're talking about, the SRS and the DSD, to understand it. Then once you've been able to understand it, then you will need to know how this one will work. So the design specification document contains detailed functional description and other information such as user interface descriptions. And then the design options are reviewed for risk, for budget, and time constraint. Because you can have this big design that is very complex that might take forever for you guys to deliver. But now you ask yourself, this is big, and maybe this is an enterprise level architecture that you have drawn. This is how the app will look at finally. But you have to ask yourself, for us to take this thing to the market, can we design up to this stage, and then in subsequent versions, we can now add this as additional features? That is how people do it. You don't just bring everything to the market. Even if you look at the architecture of an application such as Netflix, you'll discover that they started with something that is not as big as it is today, but it continues to grow because more features are being introduced. So that is the design phase. And then we look at the develop phase. Once you have designed and your designs have been approved, the actual writing of computer code starts here. You see, we have gone through 1, 2, 3 phases. Now you start writing your code at the 4th stage. The code is written according to the design specification document and the organization's software development standards and guidelines. Different organizations have their own standards and guidelines, so you need to align with that. And then you write your code, and then the programming language is chosen and is based on the type of software that will be created. So we say programming languages are not a one size fits all. You'll find that there are certain programming languages that are are well suited for certain types of applications, while others are suited for different types of applications. So choosing the right programming language is also important. So that is what we do in the developing phase. And then now when we come to the testing phase, testing is one of the most important steps in the SDLC. Why? Because here it's possible for code to be written to test other code. So that is what we call automated testing. So you can write code to test the code that you've written. Like for example, for those who are familiar with Python, if you write a Python code, you can actually write a test to test the code that you've written. Maybe things like PyCode style, linting, to check if it fits or if it aligns, let's say, for example, with standards such as PEP 8, stuff like that. So all that is possible for you to do only by you writing what? By you writing what we call test cases. Then common types of testing include the following. You have unit test, you have integration test, you have security test, and performance test. So as the name suggests, unit test, this is when you take, let's say, for example, there's this application that you've built, and then there is one bit of it or a module of it that is maybe used for the login page. You can test it to see if that one works. Integration is you now taking unit 1 and unit 2 and seeing how they communicate together. If things flow well, if nothing is broken, that is integration test, put simply. Then security test is for you to check if the code that you've written has bugs. That is security test, and that is like a full course in its own self. And then performance test, you try now and look at all this code brought together. Is it performing the way you expect it to do in terms of UI, in terms of, let's say, for example, a user logs in, are their details being captured in the database, stuff like that. So performance, that is very, very important. Again, I will invite you to read through these notes. These notes are very good because it tells us that there are many types of testing that include what you can see there: unit testing, which tests individual application components; integration testing, which tests combination of multiple application components; security testing, to check whether your application is vulnerable from internal and external threats; performance testing test to see whether the application meets its expected performance requirements. You see, security tests, they have been clear. It checks vulnerability, both internal and external. You will be surprised to note that that internal threats sometimes outweigh external threats in this sense. Without this kind of testing, it's very possible for someone to write code and then leave loopholes that maybe when I leave this organization, I can still be able to log through this backdoor and get into the systems. That's not a very good thing to do. That's unethical. And then number 2, think of things like banks. Without security test, watu wangeacha loopholes so that ukiwa penye huko you can actually get back, because some people that work for banks are not actually their developers. Might even be contractors. You leave a loophole and then now you're able to get in there and siphon some funds. If you look at some of the cases that we've had in the media of people hacked because there were vulnerabilities in those code. You know, there were vulnerabilities. Only that the people that were attacked, the organization that were attacked, cannot really come out and say, oh, sorry, it's our fault, we had some loopholes in our security testing. But those are some of the things that put things at risk. So as a good developer, be it cloud native or a normal developer, when you develop, make sure that you do all these types of tests, and it will really save you a lot of pain and make you appear good in the eyes of your customers and clients. Then we talk about implementing. So implementation is sometimes called deployment. And later on, we'll be talking about something called CI/CD, continuous integration and continuous deployment / delivery. So when it comes to deployment, the customer approves and signs off the completion of the application. So once that is done, the application is released and used in production. You see, so something like M-Pesa needs a signing off from the customer, and the customer here is not us. The customer might be Safaricom or the people that are authorized to do such sign-offs. So once it has been signed off, that's why you hear that now we have version this of Safaricom or of M-Pesa, or this other version of this. And these sign-offs happen not only at the beginning of the SDLC, but every time new code is pushed, it needs to be signed off. I know nowadays there are those automated most of these processes are automated, but if memory serves, most organizations prefer to have the deployment phase being signed off by a human being, so that at least things that might have escaped, might have passed through some tumwanya can be captured there, and also responsibility can be assigned to somebody in case things go wrong. Then finally, maintenance. Maintenance is equally very, very important. While in production, applications must be monitored constantly to ensure their correct operations. The need for maintenance can arise from different reasons, like, for example, defect or error identified. So this is what we call corrective maintenance, because that defect needs to be corrected. Then changes in application environment, adaptive maintenance. So changes in environment, you know, when M-Pesa started back in the day, some of the devices we see today were not hazikuwa zimetokezea, or maybe even someone created something like, let's say something like Facebook. You know, Facebook, maybe initially it was only accessed through what? Through the web app. But now they need to continue improving it so that hata watu wenye wako na the small sized screens for their phones, large size, different sizes can actually get good user experience when they're using that application. Then changes in application requirements, perfective maintenance. So applications keep on improving because customers also have needs, and their needs continue to evolve over time. So perfective maintenance is also important, and prevent the occurrence of errors, preventive maintenance. So preventive maintenance is what you find that maybe somebody has learned that social media platforms are being hacked. Then Facebook says we need to get ahead of this before they get to us. Let us make sure that we prevent this from reaching us. When others are being hacked, let us make sure that we learn from that and we prevent ourselves from being hacked. So they can do preventive maintenance. They say ukiona mwenzako akinyolewa lako litie maji. I don't know if that is to prepare kunyolewa or it is to make sure that nywele yako hainyoleki. I have never really gotten that clearly, but it is what it is. So that is that. Key takeaway, again, for me to breathe. Who would like to read for us the key takeaways? Somebody unmute, this time a lady. Kindly unmute and read for us the key takeaways.
A server is a computer that
Was it Amy or Sharon? Who is reading?
I'll read.
Okay.
A server is a computer that provides data or services to other computers. Second point, second takeaway, a data center is a physical location where an organization stores and operates its computer and networking equipment. Third takeaway, hardware virtualization gives you the ability to create VMS on a physical computer. It is a fundamental technology that is used in cloud computing. The last one, the following are the phases of the SDLC: plan, analyze, design, develop, test, implement, and lastly maintain.
Awesome. Thank you so much, Sharon. That was awesome. Thank you so much for reading through that. So this speaker notes are just a repeat of what we have just gone through. Thank you so much for your patience, and thank you for your indulgence. Thank you for your engagement. That was awesome. I hope you guys have learned something. Do we have any questions before we jump into our KC? We are going to do our second KC, and then we'll be done for the day. Do we have any question? Can I access my chat? I am not seeing any questions in the chat, so I guess we are good. So let us move on to the cases. We do the cases and then we'll be done for the day. So again, Gideon, you have a question?
Yes, I have a question. We talked
Yes,
about
Gideon.
reusability and portability of VMs. And I'm just wondering, compared to what?
Compared to what?
Yeah.
Yes, so you see a virtual, okay. Good question. Let me think. Would like to answer. Compared to what? And if you did not ask that question, maybe you know. Ebu tell us compared to what? Someone help us answer. We talked about reusability and portability of VMs, that VMs are reusable and they are portable. But even as we, okay, I think someone has said something kwa chat. Let me see first before I say what done. Yeah, VMs can be migrated. No, VMs can be migrated. Yes, that is true. VMs can be migrated. But now here, when you're talking about that, if English serves, I think it is not compared to what, because if you would have said it is more portable or more reusable, then we will say compared to what. These are just standalone, what do you say, attributes of virtual machines, that they are reusable and that they are portable. And by portable, it means that you can actually carry them from one machine to another and you can reuse them. To reuse, what I understand by reusing is I can use it for purpose A and repurpose it and use it for purpose B. That is reusability. Portability ni hiyo ability ya kubeba from here to here, but it is not that we are comparing it to any other thing. You know, it's not that we are comparing it to any other thing. Make sense? Oh, thank you. I did not see your thumbs up. That was a good question. Thank you. It shows critical thinking. I like it. That is very, very good. That's very, very good. And guys, let us be asking questions. Usitoke class bila with questions pending. I am moving on to the cases. I hope you guys have already, you are still on your canvas. I want us to again do these cases together. Just give me a second. What's up? Web. Just give me a second. As that is opening, we will finish this it's only 5 questions. Let us have the same level of engagement that we had when we did our first cases. And if you're not able to do it with us, just copy the answers and always go back and do it. Go back and do it. Just give it a second. Let's give it a second. Something is loading on the other side. I don't need it there. I can use my phone. It's easier. Just a second, guys. I promise I won't keep you for long. Oh, it's already loaded. So let me just open it on my computer. On my comp. This is easier. Okay, do we have someone saying something? Daniel. Daniel, unataka people wakudonatie some RAM, eh? What you have 4 GB? I can see you. I can see you. That is funny. Who wants to donate some RAM to our friend, Daniel? What is happening to that? Okay. Let me use my phone in order to save on time. Okay. So, copy this one. Okay. So I want us to start on the cases. I want us to start on the cases. Now, where is the link to this one? Okay. Sawa. So let us start on these cases. Start. Let me remove this one from here. And remember what we said. We said that you can repeat these cases as many times as possible to make sure that you get 100%. Again, you guys are free to engage with me and give me the answers. So question one, which server receives HTTP requests from clients and uses HTTP to send pages or resources back to the requester? Which server receives HTTP? Hata hujangoja swali. Hey, index 1, we can see you. That's nice. Web server, do we agree or do we have someone with a different answer? If we agree, let me just see thumbs ups. Okay, okay, good. So let us submit and see. Correct. Thank you for that. That's a good answer. Now, which statement describes the benefits of virtualization? We need two answers. Which statement describes the benefits of virtualization? Mm-hmm. A. Are you sure? I'm not saying that you're wrong. I just want you to be sure of your answer.
Yes. B also.
A. Okay. Okay. We need two answers. The second one?
D, dog.
A, B, C, D. D is this, eh? Okay.
No. Yeah.
Is that it? So you say D. This is it, eh?
Yes.
Okay. So let us try. Who was that? Who has answered? Is it Mark?
Yes, D.
Okay. Mark, prepare yourself to Kidunda. You'll have virtual Ngotos from the rest of them. Ah, good. Awesome. Wale wa Ngoto, clap for him. That was very good. That was very, very good. Okay. Question 3. Which phases are part of the software development lifecycle? You can select 2. Which phases are part of the software development lifecycle? You can select 2. I need a lady to answer this.
Analyze
Mm-hmm.
and plan.
And plan. Very good, very good. Thank you, thank you, thank you. I believe that is correct. Awesome. Let us just finish. Sorry. Another small hiccup, but we are done. We are almost done. Ooh, today is today. Okay. So let me just share. Go back to the KC. Where is the KC? Aha. Number 4. Yeah. Is my screen visible? I hope you can see it. We just have 2 questions, then we are done. Which of the following are examples of a database management system, DBMS? Select 2.
Oracle, MySQL.
Oracle and?
MySQL.
Okay, we covered this ones in class. That is good. Awesome. Thank you. Thank you. Then submit that, and then we see that is correct. Finally, very, very finally. Finally, which AWS service provider, which AWS service provides the ability to host virtual machines? Which one? We discussed it. I mentioned it. We did not discuss. I just mentioned it. Which one provides the ability to host virtual machines?
Amazon EC2.
Amazon EC2. Okay. Okay, let's see if that is the right answer. Submit. There you go. Thank you for that. That is correct. And this is what we want to see. When you submit, we want you to get this kind of a score. And that will be awesome. That will be awesome. So we are hoping that within the next 1 hour, all of you will have done your cases and you'll have submitted them, so that when we'll be checking just to close the day, we will record down that you guys have done your cases. If you have any challenge doing your cases, reach out to myself or to Joy and we will guide you. And in case you have any other challenges related to what we spoke of today, also feel free to reach out to us via WhatsApp. You have our phone numbers. Don't get stuck anywhere. We are here to help you. Again, apologies for the disruptions that we've had today in class, but I hope you guys have learned something. And so we are looking forward to continuing our lessons tomorrow. Before we end the class, let me invite Esther in case she has any announcements. Esther?
Thank you, Patrick, for we've had a very nice afternoon session. I hope everyone enjoyed. I hope you've learned something this afternoon. What I want to emphasize, kindly don't join class today, then tomorrow you pick a miss. Be consistent, guys. It is very, very important. If you feel like you won't attend class, kindly communicate prior. Let us know before. Kuna mtu mahali? Read, unasema nini? All right. So, attendance is a must. If you feel like you won't be able, communicate before. Let's over-communicate. Yes, Sharon?
I have a question.
Stop the recording, Patrick. Patrick?
Oh, yes. I'm here.
Stop the recording.
Oh, sorry. Okay. Let me do it in a show more. Stop the recording. Stop recording.
Yes, Sharon?
Awesome.